This is my beginning algebra course. Today we're going to add and subtract algebraic fractions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start with pre-algebra review. So let's get a common denominator. If we multiply both sides of this fraction by 2, we get 4x over 6. And now we have a common denominator, and we can add those fractions up to get 5x over 6. So we only had to multiply one fraction on the first problem, but on this problem we have to multiply both fractions. If we multiply this fraction by 2, we get negative 10y over 12. And if we multiply the other fraction by 3, we get 9y over 12. So now we have a common denominator. We add those up and we get negative y over 12. And remember, if your coefficient is 1 or negative 1, you don't write the 1, you just write negative y or just y. So let's try one more of these before you try some on your own. We're going to multiply both sides of this fraction by 7 to get 7z over 42, and both sides of the other fraction by 6 to get 12z over 42. And now we can combine the fractions. 7z minus 12z is negative 5z. And there you go. So now you try number, and it looks like we didn't have to simplify any of those fractions, but you might have to simplify some of these, so just be aware of that after you do the calculations. So try number 4, and when you come back, we'll do it together. All right, we're back. And I'm just going to get rid of that positive in the parentheses. (21x minus 12x) is 9x over 28. So if you got 9x over 28, good job. All right, try number 5, and when you're done, we'll do it together. All right, we're back. Y minus 20y is negative 19y. So if you got that answer, good job. Again, we have not had to simplify any of these answers yet. So try number 6, and when you're done, we'll do it together. All right, we're back. If you got that answer, good job. So we didn't have to simplify any of those fractions after we did our calculations. But just be aware that sometimes you might have to simplify some of those. For example, if you got 6z over 8, then that would simplify to 3z over 4. Stuff like that. All right, so now we go to beginning algebra. So as you can see, things are quite a bit more complicated. So there's 3 steps to solving these problems. First, you're going to factor anything that you can factor in the denominators. And it turns out you can only factor this part here. You cannot factor x minus 6 on this particular problem. So that's the first step, is factor the denominators. The second step is find a common denominator by using the fundamental principle of fractions, as we did in the previous problems. And the third step is combine the fractions by adding or subtracting. So you're probably wondering, well, why are we going to factor the denominators? How's that going to help us? Well, you'll see as we do this first problem and as we do the rest of the problems in this class. So this is a quadratic, so we need 2 pairs of parentheses. And we need to ask what 2 numbers multiply to 24, or multiply to negative 24, that is, and add up to negative 2. So let's see, it looks like that's going to be negative 6 and positive 4. So the reason that we did that is because it's going to make it easier for us to find a common denominator. Now we could just multiply both these denominators together, and that would suffice for a common denominator, but the algebra would be really difficult. But now that we've factored this expression, this is going to be really easy. So what we're going to do is we're going to multiply both sides of this fraction using the fundamental principle of fractions. We're going to multiply both sides of this fraction by x plus 4. Again, that's the fundamental principle of fractions. You can multiply both sides of a fraction by the same number, and it doesn't change the value of the fraction. So all we did was we just multiplied both sides of this fraction by x plus 4. And now, because we did that, we now have a common denominator. So we can just keep the factored form for now. We don't really need to reduce that. In fact, it's better to keep the factored form. So now we're going to multiply the numerator, so we have to use the distribution rule. And it may seem a little weird because the monomial term is on the right, but that doesn't really matter. It's still the same distribution rule. And the reason I did this on the left is because I just have more room on the left. So 2 times x is 2x. 2 times 4 is 8. So now we have a common denominator, and we can just add these up. So when you have a common denominator, you just add the numerators and keep your denominators. So 2x plus 8 plus 1, that would be 2x plus 9. And if you want to, you can go ahead and FOIL the denominator. But the reason that we kept the denominators factored is because sometimes you can reduce afterwards. Just like in the previous problems, I remember I mentioned that sometimes you can reduce when you get your answer. So if we ended up, for example, with x plus 4 here, well, let's say that we ended up with 2x plus 8. Then we could factor this. If we factored 2 out, we'd end up with x plus 4, and then 4's would cancel out. So that's why you want to leave it in factored form in the remote chance that we might be able to reduce when we get our final answer. So I don't really have any room to perform FOIL, but I don't really need to perform FOIL. You can just leave it like that. But just be aware that when you look in the textbook, when you look at the answer, they may have the denominator FOILed out. So if you FOIL it, you get 2x plus 9, and then FOIL first terms, outside terms, inside terms, last terms. And then, of course, you add these together and you get negative 2x. And you just get right back to where you started. You get this You get this denominator right back where you started. So we don't really even have to FOIL. We know it's going to be this. So you would just rewrite this down here. That's another way to do it. But I don't really care. You can just leave it in this factored form because what's the point in wasting time foiling it back there? There may be a reason to do that, but I don't really care in this class. The main point is that you you learn the concepts of adding or subtracting fractions. So now let's try number 8. Again, the first step is to factor the denominators if you can. We cannot factor 3b. There's nothing to factor. But there is a factor that we can take out of 3b minus 3. We can factor out 3. So that's the first step, is to factor out the denominators. Factor the greatest common factor if you can. And now we want to use the fundamental principle of fractions to get a common denominator. So we have 3's They both have 3's, so we don't need to worry about the 3's. And but the problem is we have a b minus 1 here, but we don't have a b minus 1 on this fraction. So we're going to have to multiply both sides of this fraction by b minus 1. And so now we have a 3b and a b minus 1. So we have we have 3 things. We have a b, a 3, and a b minus 1. Those are all factors. So now we need those same 3 factors over here. We have the b minus 1 and we have the 3, but we don't have the b factor. So we're going to have to multiply both sides of this fraction by b, and it's probably best to keep it in parentheses. So now we just multiply b minus 1 times 1 is b minus 1. And we're just going to keep that in factored form like we did on the previous problem. And let's multiply the numerators first. 4b times b is 4b squared. And again, it's traditional to keep the monomial on the left side, combine all the monomial factors. And now we have a common denominator. So now we're ready to combine. But just be aware that you're subtracting this fraction. So this is a positive 4b squared in the numerator, but because you're subtracting this whole fraction, when you combine the numerators, you're going to consider this to be minus 4b squared. And we cannot combine that with anything else, so we're just going to write minus 4b squared, and then plus b, because that's a positive b, and minus 1. And again, we could not combine any of these because they're not like terms. We have a squared term, a first power, and a 0 power term. So we cannot combine those expressions. And we just rewrite the denominator, and we're done. So on to number 9. We're going to do one more of these problems before you try some on your own. Now this is a case where we cannot factor the denominators. There's nothing really to factor. We're going to skip step number 1 and multiply both sides of this fraction by a minus 5. So again, why are we doing that? Well, you're going to see why we're doing that. It's going to give us a common denominator. Multiply both sides of this fraction by a plus 3. This is just the easiest way to get the common denominator. And I want you to be very aware that when you multiply a binomial by another binomial, you see how I added these parentheses? The parentheses were not on the x minus 6. But then when I multiplied, I had to add the parentheses. So I should have been more clear about that. Here, I'm multiplying a minus 5 times a plus 3. This is not correct unless I put these parentheses around the a plus 3. That's another source of error. Same thing over here. I need parentheses around the a minus 5. That's another potential source of error for students. If you don't put those parentheses, you're going to confuse yourself and get the wrong answer. So now, we're going to go ahead and distribute on the top, and we get 2a minus 10. And the bottom we have a minus 5 times a plus 3. And over here we're going to distribute 4 times a plus 3. That would be 4a plus 12. And so again, why did we do that? Well, because now we have a common denominator. And in algebraic terms, it just happens to be the lowest common denominator. There's a lot of different ways we could do this, but this is the easiest way. So now that we have a common denominator, and again, I could FOIL these out, but we want to keep those factored because we might be able to reduce. So now that we have a lowest common denominator, we can go ahead and add these fractions together. 2a plus 4a is 6a. Again, we're just adding the numerators. Negative 10 plus 12 is positive 2. And again, you can FOIL the denominator, but we don't really need to. When you look at in your book, when you look at the answer in the book, this is probably going to be FOILed. So that's something you need to be aware of. I would FOIL it if I had more room, I guess, but I don't think you really need me to FOIL it. I think you get the idea. Now, we could factor out a 2 here, but we'd get 3a plus 1, and there's no 3a plus 1 in the denominator, so we cannot reduce that. All right, so hopefully you got the idea. Again, just review here. The first step is to factor the denominators, if you can. Factor what you can. And the second step is to use the fundamental principle of fractions, like what we did here, to get a common denominator. And the third step is to combine, like we did here. So try number 10, and when you come back, we'll do it together. All right, we're back. So first step is to factor. So we can factor the denominator on the left fraction, but not the denominator on the right fraction. And now we're going to multiply both sides. Well, let me see here. Yeah, I should probably do an extra step for that. Before I use the fundamental principle of fractions, I'm going to rewrite. I'm trying to take it slow here. Show each step. So I'm going to multiply both sides of this fraction by x plus 6. And why am I going to do that? Well, because that gives us a common denominator. Very simple. But I have to add parentheses on the x minus 3. I must do that, or else it's not correct language. If you just write x minus 3 times x plus 6, then what this is telling you is you're multiplying x plus 6 times negative 3. But you're not multiplying x plus 6 times the x. So that's incorrect. You have to put parentheses, or else you're not going to be writing correct notation. That's like saying, I go store celery. That doesn't mean anything. You have to say, I am going to go to the store to get some celery. All right. Let's see here. So now we're going to multiply. 1 times x plus 6, of course, is just x plus 6. And now we have a common denominator. So again, why did we do that? Well, because now we have a common denominator. It's very simple. So let's see. Now we can add the fractions up. I'm going to move this down a little bit. So 4 plus x plus 6 is x plus 10. Again, you just add you combine the numerators, add the numerators, and keep the denominators. And again, it's traditional to write the numerator in descending order of powers. So this is first power, this is technically 0 power. I know we haven't discussed why that's called 0 power, but it's not really that important. Just write your x first. It's not really wrong to write the 10 first, but anyway, let's go on to the next problem. So try number 11. Again, first step is to factor. You cannot factor 2c. There's nothing to do there, but there is something you can factor out of here. So factor and then get a common denominator using the fundamental principle of fractions and then combine. So try number 11. When you come back, we'll do it together. All right, we're back. We're going to factor out 2. 2 can factor out. I'm going to write that a little bigger. All right. So we factored. That's the first step. There's nothing else really to factor. And now that allows us to see a common denominator. So this is the type of problem where we're using all those colors. They both have 2's, so we don't need to worry about the 2's. They both have 2's. But one of them this one has a c, and this one doesn't have a c factor. This one has a 5c minus 2 factor, and this one doesn't have a 5c minus 2 factor. So because this one doesn't have a c, we're going to multiply, and I'm talking about the denominators. I'm not talking about this c. So we're going to multiply both sides of this fraction by c. And this fraction doesn't have a 5c minus 2 factor, so we're going to multiply both sides of this fraction by 5c minus 2. And you have to use parentheses because it's multiplication. All right, so I'm going to move this down a little bit. So c times 3c is 3c squared. And I'm just going to combine the bottom. And 5c minus 2 times 1 is just 5c minus 2. And there we go. Now we have a common denominator. Again, if you're struggling to understand why we did it that way, it's just because now we have denominators that are exactly the same. It's very simple. It's the easiest. It's not the only way to get a common denominator, but it's the easiest way. All right, so now we're going to add the numerators, and we can't really do much. We can't really combine anything in the numerators because they're unlike terms. Now we might be able to factor this out, but I can already tell we're not gonna come up with a 5c because there's a 3 in front, so that it's not going to reduce. So that is going to be our answer. So if you got that answer, good job. All right, so try number 12. You can use number 9 to help you. Whoops. You can use number 9 to help you with number 12. And when you come back, we'll do it together. All right, we're back. So we're going to multiply both sides of the left fraction by a minus 2. And there's no, by the way, I didn't mention, we cannot factor the denominators. There's nothing really to factor. And please be aware that you need to put parentheses. Maybe I should use another color for that just to emphasize that. We need to put parentheses around the a plus 1 and the a minus 2. But I should probably just stick with black. All right, so now we're going to multiply the numerator, 2 times a minus 2, using the distributive rule, is 2a minus 4. And we're going to keep the denominators factored. We could FOIL it out if we want to do, but it's best at this point just to keep it factored. A plus 1 times 1 is a plus 1. And just write the denominator. So now we're ready to combine 2a minus 4 plus a plus 1. That would give us 3a minus 3. And I almost got excited there because it almost looked like we would be able to reduce this fraction, because if you factor out a 3, you get 3 times a minus 1. If we had an a minus 1 in the denominator, If this were an a minus 1, then we could actually reduce that. But since we don't have an a minus 1, and we really cannot reduce it. So that would be our final answer. Now again, you can FOIL this out if you want to. Your textbook might have the answer with the FOILed out denominator. And maybe I should just write that just so you can see exactly what I'm talking about. I think you know what I'm talking about, but you may see the answer written like this in the denominator. So just be aware of that. I'm not going to do that extra step because we don't really need to. So if you got that answer, good job. So in those problems, we were adding, well actually I guess we did one when we were subtracting. Now for number 13, some different things are going to happen. This is where some error starts to come in, and it starts to become a serious problem with students because you're subtracting this expression. And so let's do 13 together. We cannot factor anything in the denominators. We're going to multiply both sides of this fraction by y plus 7. And we don't need parentheses here because it's not a binomial. So there's no danger of confusion. And we're multiplying both sides of this fraction by y. So now we have a y plus 7 factor and a y factor in both the denominators. So 3 times y is 3y. And we'll just put the y right next to the y plus 7. Keep it in factored form. And we're going to distribute 4 times y plus 7. 4 times y is 4y. 4 times 7 is 28. Now, here's where the confusion comes in. This is going to be a huge source of potential error for you when you're doing your homework. This is what really frustrates students. So you really got to pay attention to this. I'm going to shrink this. We have a common denominator. We got our common denominator. And now we're going to combine the numerators. But we're subtracting this fraction. So everything in the numerator, and I mentioned this, everything in the numerator is going to change signs. So both these terms, 4y and 28, are positive right now. But because you're subtracting this whole fraction, you have to change all the signs in the numerator. Now please understand, you're not changing any signs down here. You can change either the signs here or here, but you can't do both. So we're just going to change the signs here. So that's going to be 3y minus 4y minus 28. So again, these are positive, but they change to negative. So I have no more room, so I'm going to have to go to the right over here. And now we can do 3y minus 4y is negative y. And just rewrite the 28. And we're done. So again, please understand that that's a potential source of error. That's probably the number one error that students make when it comes to these problems, is when you're subtracting, all the signs in the fraction that you're subtracting in the numerator change. So if this were, for example, a negative 4y, it would change to positive 4y, so on and so forth. All right. So why don't you try number 14? 14 is not a subtraction problem, so it looks like it's going to be pretty standard. Again, we're just doing problems to get the hang of it here, so try 14, and when you come back, we'll do it together. All right, we're back. So first step is we're going to factor. Again, in the previous two problems, we didn't need to factor, but in this one, we definitely do. So now we can see what we need to do after factoring. And I'm going to shrink that a little bit. we're going to multiply both sides of this fraction by z plus 5. Again, you have to add your parentheses on the z minus 2. So now we're going to get a common denominator. So we have 5z. We just rewrite that fraction. And 1 times z plus 5 is z plus 5. And just rewrite the denominator. All right, so 5z plus z plus 5. Again, we don't have to worry about signs here because we're not subtracting. So 5z plus z is 6z. So we're left with 6z plus 5 over z plus 5. And I'll move this over here. In fact, I'm just going to write an equal sign and put it over here. Now that's not going to work either. Just move it up. And there we go. So if you got that answer, good job. All right, so on to number 15. We have a situation here where you have a negative in front. So whatever the numerator ends up being here, you're going to have to change the signs because this negative goes along with the numerator. So if you'd like to try this problem, go ahead and try this one. But be aware it's going to be a little tricky with that sign here. So if you get stuck, we'll do it together. So pause the video, try it on your own, and when you come back, we'll do it together. All right, we're back. So the first step is to factor. We have 2 quadratics, so we can definitely factor. All right, so we have an x minus 8 in both fractions. But on this fraction, we have an x plus 2, and we don't have an x plus 2 on this fraction. In this fraction, we have an x plus 5, but we don't have an x plus 5 in this fraction. So we're going to have to multiply both sides of this fraction to get an x plus 5 there. So I'm going to take this and move it over a little bit so I can fit it on the other side. So multiplying both sides by x plus 5. And over here, I'm going to multiply both sides by x plus 2. All right. So now x plus 5 times 1, and we can just take this negative. The best thing to do is really just take this negative and just put it up with the 1. That's going to make things a lot easier. So x plus 5 times negative 1. You just distribute negative 1 times x is negative x. Negative 1 times negative 1 times positive 5 is negative 5, and there you go. And 2 times x plus 2 is 2x plus 4. And whoops, I forgot to write my other factor on the denominator here. Let me move that over. And now, We just have to combine the fractions. So the third step is to combine the fractions. So negative x plus 2x is x. Negative 5 plus 4 is negative 1. And just write the denominator, and that is our final answer. So if you got that answer, good job. All right, on number 16. So for number 16, we have the same situation that we had here. You have this negative on number 13, and the potential source of error is when you subtract, you need to change the signs. So go ahead and try that for number 16. When you come back, we'll do it together. All right, we're back. So we're going to multiply both sides of this fraction by y plus 5. And both sides of the other fraction by 2y. And because this is a binomial, I need to put parentheses around the y plus 5. 2y times 2 is 4y. And keep the denominator in factored form. And 3 times y plus 5 is 3y plus 15. And again, keeping the denominators factored. So now we have a common denominator. But again, this is the potential source of error. You have to really worry about the signs here. We're subtracting, so these are both positive. 3y and 15 are both positive, but they're going to become negative. So that's going to be 4y minus 3y. 4y minus 3y is going to be y. And this is not going to be positive 15. A lot of students would just say, okay, I'm done, 15, put the denominator, I'm done, then go on to the next problem. Nope, that's not correct. You're subtracting, so it's not only 4y minus 3y, but it's also a negative 15. You have to change that to a negative 15. Again, that's the most common source of error for these problems. So there's nothing to factor, so that is the answer. So if you got that answer, good job. All right, so try number 17, and when you come back, we'll do it together. All right, we're back. First step is to factor. And that allows us to see what we need to do. So that's telling us that we need to multiply both sides of this fraction by z plus 1. And there's really nothing that we need to do to the fraction on the left. All right, so again, just rewrite the fraction on the left. And distribute 2 times z plus 1, use the distribution rule. And now we have a common denominator, so we're ready to combine. So 3z plus 2z is 5z. Then we have our plus 2. And And we're done. So if you got that answer, good job. Now, if this, again, if this were z minus 5 or z plus 2 or something you could factor so you could get one of these factors down here, you could reduce it, but that rarely happens. But just be aware that if the answer in your book is different, then they might have reduced it. All right. So for number 18, we're going to have that problem. Remember, I was talking about that problem where you're subtracting. You have to change the signs in the numerator, so be aware of that. Try number 18, and when you come back, we'll do it together. All right, we're back. So first step is to factor. You're probably wondering why I don't just copy and paste instead of having to write all that out. Well, it's because I can't paste onto a picture. This lined paper is actually a picture. It'll paste it off to the side. I won't paste it on top of the picture. So it's annoying. All right. So now we're going to multiply both sides of this fraction by x minus 2 because it doesn't have an x minus 2. And we're going to multiply both sides of this fraction by x plus 3. I'm going to move that over a little bit. And put a divider just in case there's a confusion. So now distribute 3x minus 6. And 1 times x plus 3 obviously is just x plus 3. And so now comes the tricky part. These terms are both positive. But I want to demonstrate, well, I guess I can't do it now, but if this were, be aware, if this were a negative 3, we haven't seen this problem yet, but let's say that this were a negative 3. All right, so let's say that we're minus 3. It's not minus 3, let's say it's minus 3. Because we're subtracting this fraction, you would have to change this x to a negative x because it's positive x right now, but you'd have to change it to negative x. And this negative 3 is negative 3 right now, but you'd have to change it to a positive because you're subtracting. So that you'd have negative x plus 3, and you'd get rid of this negative sign and become a positive sign. So just be aware of that, but that's not negative 3, that's positive 3. All right, so we're subtracting both of these. So it's going to be 3x minus x, not plus x, 3x minus x. So that would be 2x. And this is going to be negative 6 minus 3, not plus 3, minus 3. So it's going to be negative 9. So if you got that answer, that's very good. That was a challenging problem. All right. So on to number 19. Go ahead and try 19, and when you're done, we'll do it together. All right, we're back. Nothing to factor on this problem. But But again, I don't mean to sound like a broken record, but you got to add the parentheses around the y plus 4 and the 2y minus 1. Or else it's not correct language. You're telling people to do something that you don't really want to do. All right, now we distribute y plus 4 times y is y squared plus 4y. And 6 times 2y minus 1 is 12y minus 6. Again, just using the distributed rule. And now we can combine, because we have a common denominator. So remember, you can only combine like terms. We learned this in the class on polynomials. You can't combine y squared with anything, so we'll just write y squared. But you can combine the 12y and the 4y. That would be 16y. And again, we don't have a negative here, so we don't have to worry about changing these signs. And then we just add the negative 6. There's nothing to combine the negative 6 with. Now, if we could factor this, then we might be able to reduce, but I can see that that's probably not factorable. It's not easily factored, so you don't have to worry about that. So if you got that answer, good job. Now for number 20, something very, very different is going to happen. So we need to do that one together. So the first step, as usual, is to factor whatever you can factor in the denominators. And then we're going to get a common denominator. So this is where something different is going to happen. You can see that we don't have any common factors in the two denominators. So what we're going to do is we're going to multiply both sides of this fraction by z. That's the easy part. So now we have a z in the denominator here. But unfortunately, we have to multiply both sides of this fraction by all of this. That's where the difficulty comes. So we're going to multiply by a lot of stuff. So I'm multiplying both sides of this fraction by z minus 3 times z minus 1. So this is the part that's going to be a little weird for students. You're not going to like this, trust me. You're not going to like it. 2 times z is 2z. And we can just leave the denominator in factored form. And again, it's traditional to put the monomial farthest to the left. So we're done with this fraction. We've got that in the form that we want it. And again, all we're doing is just changing forms of fractions. And we can just go ahead and write the denominator, no big deal, over here. So up until this point, again, everything is really easy, everything is simple. But here's where the difficulty comes. So I want you to be aware there's a lot of different ways we could do this. We have to multiply all of these terms, and we cannot leave the numerator here in factored form. Again, we've been keeping all the denominators in factored form, but the numerators you cannot keep in factored form. We actually do have to multiply. So one way to do this is we can go ahead and FOIL this out, and then we can multiply by 3, or we can take 3 and multiply it into one of these, and I stress one of them. You're not going to multiply into both of them. And that brings me to an important point. I don't mean to go off on a sidetrack here, but when you're multiplying, for example, let's say 3 times a plus b, you use the distributive rule, and you end up with 3a, if I can write the 3a properly, 3a plus 3b. All right? You agree with that probably. But when you're multiplying 3 times a times b, you don't distribute. It doesn't become 3a times 3b. It's extremely important to understand. A lot of students confuse that. So if you didn't understand that, don't worry about it. But when you all I'm saying is that when you multiply this 3, you don't multiply it into both these, because this is a product. It's not a sum. The insides are technically sums if you consider a negative number here, but the overall expressions, they're multiplied. So you don't multiply 3 into both of those. So you can multiply 3 into one of these, and then you can use FOIL. But I think it would probably be easier for me to just FOIL this out, then multiply by 3. So I'm going to go ahead and do that. Now the good news is we don't really have to think about how to do that, because we already have the we know what that expression equals. It's down here, or up here, I mean. So that just becomes z squared minus 4z plus 3. Or z squared minus 4z plus 3. Now I'm going to move that down because it's starting to get a little confusing. So again, I multiplied all of this into 3, but I just foiled it out first. So I'm going to color code this. So this blue part became all of this, and the green 3 is still there. So now all we have to do is multiply the 3 into this trinomial. So 3 times z squared is 3z squared. 3 times negative 4z is negative 12z. And 3 times 3 is 9. And I'm just going to have to go down and probably shrink some of this. All right, so finally we have a common denominator, and we can go ahead and combine those. So remember, this is a positive 2z, but it becomes negative because we're subtracting it. So we first write the 3z squared. We can't combine that with anything. And then negative 12z minus 2z is negative 14z, and that would be plus 9. Again, the 9 does not change. Please understand that these signs do not change because you're not subtracting this fraction. Now, in the case where we had a negative in front of the fraction up here, then we brought this negative up and everything here changed. But because we have a positive fraction here, these signs don't change. All right, so then we just write the numerator, or excuse me, the denominator. And it looks like that's it. There you go. All right, so why don't you try 21? That's going to be a similar problem. And when you come back, we'll do it together. All right, we're back. As usual, the first step is to factor the denominators if you can. Now we're going to have to multiply both sides of this fraction by y. We'll start with the easy part. And you must put this in parentheses here because you're multiplying by a binomial. Just make sure to put your parentheses. That's the safe thing to do. All right, and we're going to multiply both sides of this fraction by y minus 1 times y minus 1. Now, I want you to be aware, there's a possibility that what you did is you multiplied both sides of this fraction by only one y minus 1. You didn't multiply by both of them. Please be aware that if there's two y minus 1s here, you have to have two y minus 1s here, or else it's not going to be a common denominator. So if you made that mistake, that's okay. Just go back and fix it. So let me double check everything, see if we got everything set up properly. Looks correct. So again, you can distribute the 4 into one of these, and I stress one of them. Then you can FOIL, or you can just FOIL this out and multiply by 4. So that's what I'm going to do. But first, let's do the easy part. So y times 3y minus 5 is 3y squared minus 5y. And then I'm going to I'm going to FOIL that out. But we know when we FOIL it, we get this. So we don't really need to do all that math. I'm going to get 4 times y squared minus 2y plus 1. All right, so now I have to multiply 4 times all of this. And it would be much easier just to take this negative and put it up with a 4. And then you can just change this to the connecting sign to a positive. So this should just be a negative 4, and then you'd be adding. But I'm not going to do that. I don't want to confuse you. I want to do this problem the same way we did the other problems. So 4 times all of that, use the distributive rule. We get 4y squared minus 8y plus 4. All right. I'm going to move these down a little bit. And then you can just change all these signs to negative. So this is going to be 3y squared minus 4y squared, not plus 4y squared. This is a positive 4y squared, but it's going to become negative because we're subtracting it. So 3y squared minus 4y squared is negative y squared. And negative 5y plus 8y. Do you see that? This is a negative 8y. But because we're subtracting this whole fraction, it's going to become positive 8y. So that's negative 5y plus 8y is 3y. And this is not going to be a positive 4. It's going to be a negative 4. Again, that's the major source of error when students do these types of problems. Now, I also want you to be aware that this y minus 1 times y minus 1, that can also be written as y minus 1 to the second power, and I can pretty much guarantee you that that's the way your book is going to write it. So if you look at the answer in the back of your book, and you see y minus 1, you see this expression in place of this expression. That doesn't mean that you got the answer wrong. They just wrote it in a different way. So math is particularly difficult when the answers can be written in different ways. A lot of times students will get the right answer, but the book will give it in a different form, and they'll think that they got the problem wrong, and it'll be very frustrating. All right, so if you got the right answer on that one, good job. Now 22, something different is going to happen. We have more math to worry about here. So let's go ahead and try it. So we cannot factor anything. Whoops, my computer went haywire there. So there's nothing to factor. So we multiply both sides of this fraction by x minus 1. And both sides of this fraction by x plus 4. And notice I'm putting the parentheses around the binomials. And here's well, let's do the easy part first. So 2 times x minus 1 would be 2x minus 2. And here's the different part. When we multiply there, we've got to use a FOIL to multiply that. So a lot of students are not going to predict that, but that's what you have to do. We're multiplying, aren't we multiplying x plus 4 times x plus 5? That's multiplying two binomials. We learned how to do that. We had an entire course, or excuse me, an entire class just on multiplying binomials, so we know how to do that. So FOIL. First terms would be x squared, outside terms 5x, inside terms 4x. Add them up and you get 9x, and then 5 times 4 is 20. So I combined the inner terms in my head. The outside is 5x, the inside is 4x, right? And then you add those up and you get 9x. So please don't be confused by that. I did that in my head. And you need to get to the point where you can combine those inner terms in your head. It's going to get pretty tedious if you have to show that every time. If you have to show the inner terms every time you FOIL. All right, so now we're ready to just add those up. So again, the only difference with this problem is that you had to use FOIL when you use the fundamental principle of fractions. So x squared, we can't really combine that with anything, and 9x plus 2x is 11x. And again, we're adding, so we don't have to worry about changing these signs. And this is a positive fraction, so we don't have to worry about taking a negative and moving it up and changing those signs. And 20 minus 2x is 18. You know, I have a really big suspicion here. Actually, never mind. I thought that we might be able to factor that and reduce that fraction, but I guess not. All right, so number 23 is going to be similar. So why don't you try number 23, and you can use 22 to help you. And when you come back, we'll do it together. All right, we're back. So nothing to factor. You might think that we need to use the -1 rule here, and we could, but we don't really need to in this problem. And please be sure to add the parenthesis around the x plus 9. Parentheses. And please add the parentheses around the x plus 2. If you don't do that, you're not using proper language. You're saying go to the store when you really mean go to the beach. It doesn't make any sense. All right, let's double check everything there. That looks right. So now, again, we have to use FOIL here, but let's do the easy part first. 2 times 5 minus x. Now we have to FOIL this out. So again, I'm going to add the inner terms in my head. 2x and 9x is 11x. And then we get 18. That's the same expression we got in the previous problem. And then the bottom, of course, we can keep in factored form. So again, I did O and I. I combined the O and I terms in my head. So 2x plus 9x is 11x. It's okay to do that in your head. You don't have to show that because it's going to get real tedious if you have to show that every time. Alright, so now we have a common denominator, so we just add everything up. X squared, we can't really combine with anything. 11x minus 2x is 9x. And then 18 plus 10 is 28. Again, these signs do not change because we have a positive. So that's going to be negative 2x. 11x minus 2x is 9x. And this sign is not going to change. It's still positive 10, so 18 plus 10 is 28. And of course, we just rewrite the denominator in factored form. And I don't think we can factor that very easily. So if you got that answer, very good. So in problem number 24, we have the difference of two squares for the first time today. Remember, that's just going to be what number times itself equals 16, and then put your plus and minus. Also be aware that you're going to have to deal with signs over here. Be careful with your signs, because you're subtracting whatever's going to be in the numerator, so the signs are going to switch. So why don't you try number 24. And if you get stuck, that's okay. We'll do it together. Pause the video, and when you come back, we'll see what we can do. Alright, we're back. So first we're going to factor the difference of two squares. 4 times 4 equals 16, and put your plus and minus. And now we're going to factor out a common factor. We haven't done that much today, so we're going to factor out a z. And that allows us to see what we have to do. So let's rewrite. We have z minus 4 and z plus 4 here, but we don't have a z over here, and we do have a z here. So we're going to have to multiply both sides of this fraction by z, and we don't need to multiply by z plus 4 because we already have a common z plus 4. So we're going to multiply both sides by z. It's probably best to put parentheses. And over here we have a z and a z plus 4, but we do not have a z minus 4, so we're going to have to multiply both sides by z minus 4. So now, as you can see, we have a common denominator. So let's just multiply. 2 times z is 2z. And now we're going to have to distribute. 3 times z minus 4 is 3z minus 12. Let me move that over. So we're going to have to shrink all this. And now we're ready to combine. Now here's where the sign problem comes in. We're subtracting all of this. So that means when you combine the numerators, you have to change the signs of all these terms. So this is a positive 3z, but it becomes a negative 3z. And this is a negative 12, but it becomes a positive 12. So we have 2z minus 3z is negative z. And we have minus negative 12, and then we're subtracting, so it becomes positive 12. And then we just rewrite the denominator. So if you got that answer, good job. All right, on to number 25. Try number 25, and when you come back, we'll do it together. All right, we're back. So as usual, the first step is to factor. And I don't know if that's going to work, so I have to test that denominator on the left side. O term is 3y, inner term is 2y, add them up you get 5y, so that did not work. So I'm going to switch the 2 and the 1. Outer term is 6y, inner term is 1y, add them up you get 7y, so that works. Alright, so the first step we factored, and the second step now is to get a common denominator, so we're going to have to multiply both sides of the fraction on the right. So we're going to multiply both sides by 3y plus 1. So we'll just rewrite this. We're going to distribute. So we get 6y plus 2. Then we can add up 6y plus y is 7y. 5 plus 2 is 7. And we have 3y plus 1, just rewrite the denominator. So if you got that answer, good job. Now if you factor out a 7, we have a y plus 1 factor, but there's no y plus 1 in the denominator, so we can just leave it like that. Alright, so for number 26, you're going to have to worry about the sign here. Remember, you're going to change the signs up here, so go ahead and try 26, and when you're done, we'll do it together. Alright, we're back. First step is to factor. And we're going to multiply both sides of the fraction on the right by z minus 2. So we'll distribute. We get 2z squared minus 4z. So now, again, because we're subtracting, let me move this over a little bit. Because we're subtracting the fraction on the right, all these signs are going to change. So that's going to become a negative 2z squared. And we'll write in descending order of powers as usual. And this is going to be a positive 4z. And there's nothing really to combine. And this 2 comes from here, and it's positive. Let's see, negative 2. I want to see if I can factor anything. Doesn't look like we can really factor anything, so there you go. That's your answer. So if you got that answer, good job. So for number 27, looks like it's going to be pretty standard. So why don't you go ahead and try number 27, and when you come back, we'll do it together. All right, we're back. And I think we had this factor in a previous problem, if I remember correctly. So we're going to multiply both sides by 2y plus 3. And we're going to put those parentheses around the y plus 2. And we have 2y plus 3 over y plus 2 times 2y plus 3. And now we're ready to combine. Y plus 2y is 3y. Negative 3 plus 3 is 0. So if you got that answer, good job. So for 28, something special is going to happen. So let's go ahead and factor. We have the difference of two squares. But we have to stop here. Notice that we have 2z minus 3 and 2z plus 3. And over here we have 2z minus 7. So in this case, factoring actually didn't help. That doesn't really help us at all. It actually it'd be better for us to just keep it in this form, because this 2z minus 7 is not a common factor for this denominator here. So what we're going to do is we're just going to erase this and just go back to the 2 over 4z squared. So that's a rare situation where factoring doesn't really help. It seems as though we should factor the z squared minus 4, but it actually didn't help. You're not going to get very many problems like that, but you may get some. So what we're going to do is we're just going to multiply both sides of this fraction by 2z minus 7. And please add those parentheses on the 4z squared minus 9. And multiply both sides of this fraction by 4z squared minus 9. Now, if we had factored 4z squared minus 9 and we tried to multiply it, we'd have a much bigger expression over here where I'm writing right now. And that would make things harder. Now, please put the 2z minus 7 in parentheses. All right, so we're going to distribute. 2 times 2z minus 7 is 4z minus 14. See, it's so much easier just to keep it in this form on this particular problem. And, whoops, I forgot to distribute. Actually, I forgot we don't need to distribute, we just need to write that 2z minus 7 times 4z squared minus 9. And up here, we need to use the distribution rule. 2z times 4z squared is 8z cubed. And 2z times negative 9 is negative 18z. And now we have a common denominator. But be careful of these signs. So that's going to be negative 8z cubed. Again, it's a positive 8z cubed now, but because we're subtracting the whole fraction, it becomes negative 8z cubed. And we have 4z plus 18z. It's plus, because it's negative now, but when you subtract it, it becomes positive. So 4z plus 18z is 22z. And then we just have the minus 14. So again, this was a weird problem because we had the difference of two squares, but it ended up not really helping us as far as the problem went. So we may see another one of those problems, we may not. Just double checking that. Everything looks good. On number 29. Okay, number 29 is going to be a little different because we have a whole number. So what we have to do is we have to turn that into a fraction by writing over 1. Remember, any whole number can be written as over 1. In fact, pretty much anything can be written as over 1. So we have a y plus 9, a y, and a 1. So the 1 factor is, we're not really going to have to think about that, but we do need to multiply both sides of this fraction by y and also 1. But again, we don't have to think about 1 because 1 doesn't really change anything. So we're going to multiply both sides by y and put parentheses around the y minus 5 and the y plus 9. And then we're going to multiply both sides of this fraction by y plus 9. So let's move that over a little bit. Again, we're using the fundamental principle of fractions. And then we're going to have to multiply both sides of this fraction. And I guess I could do it on the other side if I really wanted. It doesn't really matter what side you do it on when you multiply. I'm going to multiply both sides of this fraction by y times y plus 9. Because I need both the y and the y plus 9. And I'm going to have to put parentheses around the negative 2, or else it looks like I'm subtracting. So over here I get, if you use distribution, I get y squared minus 5y. We can just keep the denominator in factored form. And over here, y plus 9 times 1 is y plus 9. And again, keep the denominator in factored form. And over here, this is going to get a little tricky. So what we want to do first is we want to combine the negative 2 and the y. So I don't have a lot of room, so I'm going to go ahead and do that in my head. So just negative 2 times y is negative 2y. And then negative 2y times y plus 9 is going to be negative 2y squared. And negative 2y times 9 is negative 18y. So I did a little bit, I did one more step in my head. So hopefully that didn't confuse you. Again, we're combining the negative 2 and the y first, then we're distributing the negative 2y to y plus 9. You can do it, you can multiply negative 2 into the y plus 9 first, then multiply that by y. Or you can multiply y into y plus 9 and then multiply that by negative 2. So there's a lot of different ways you can do it because of the commutative rule of multiplication. Alright, so I'm going to shrink all this. So now we can combine, and we have negative 2y squared and a y squared. So that would combine to negative y squared. And we have negative 18y and negative 5y. So we can combine all those. I think that's going to be negative 22y. And then we have plus 9. And we just rewrite the denominator. So there you go. Alright, so why don't you try number 30, and when you come back, we'll do it together. Alright, we're back. We'll write the 3 as over 1. And multiply both sides of this fraction by 2y. And please put the y minus 3 and the y plus 5 in parentheses. And multiply both sides of this fraction by y plus 5. And you don't need parentheses here because that's just a monomial. So again, you have to multiply by both factors. All right, so let's do the easy part first. Y plus 5 times 1 is y plus 5. It's traditional to write the monomial first. Over here we have 2y times y plus 3. And I just prefer to combine the 3 and the 2y first. That would become 6y. And I'm going to go ahead and, we're running out of room, so I'm going to go ahead and multiply 6y times y plus 5. So that would be 6y squared. And 30y. And 2y times y plus 5 times 1 would just be 2y times y plus 5. Now we need to move this over a little bit. And we're going to put the subtraction sign there. Now it's extremely important that when you combine these that you realize that we're subtracting this fraction, which means that all of these signs are going to change. So this is going to change from a positive 2y squared to a negative 2y squared. And this is going to change from a negative 6y to a positive 6y. So we have 6y squared minus 2y squared, which is 4y squared. And then we have y plus 30y is 31y. And then we add 6y, so we get 37y. And then we just have plus 5. And rewrite the denominator. So if you got that answer, good job. So 31 is going to be a standard problem. So let's see if you can do it on your own. And when you come back, we'll do it together. All right, we're back. Again, this is the difference two squares. And we're going to multiply. Well, first let's rewrite. Multiply both sides of this fraction by 5x minus 1. And we get 10x minus 2. And so now we have a common denominator. Now we just have to combine the fractions. X minus 7. 10x plus x is 11x. And negative 2 plus negative 7 is negative 9. And there you go. So on to number 32. Now, number 32 is going to be pretty challenging, so let's try that one together. So we're going to factor out 4z looks like we need, whoops, we need to factor out 4z squared actually. So now that we've factored, let's rewrite. Again, I'm showing every step here. You're probably thinking it's really boring to have to rewrite all this stuff, but welcome to algebra. There's no way around it. You just have to write a lot of stuff in algebra, and that's one of the reasons students don't like algebra. You have to show all your work. Again, the most important thing about this course is learning the language of algebra. You have to write it in order to show it. If you don't write it, you don't show it, you don't know it. At least you can't prove that you know it. All right, so the reason this is going to be difficult is because we have nothing common in here except one z. We have a z here and we have a z here. It's combined with that z squared. So this is going to be something very strange. Let me smooth that over a little bit. All right. And shrink this. So we're going to multiply both sides of this fraction by 5. Because we have a 5 here, we don't have a 5 in the fraction on the left. I'm going to put that -4 in parentheses just so there's no confusion. And we're going to multiply this fraction by a lot of stuff. We have to multiply by a 4. We have to multiply by a z. And please understand that we only have to multiply by one of the z, one z. We don't have to multiply by z squared, because we already have a z here. So we don't need to multiply by z squared, because then we would end up with z cubed. We don't want z cubed, we want z squared. If you don't understand that, you'll see when we get the denominator. So 4z and then z minus 4. So we had to multiply by all that stuff. That's why this problem is more difficult. And I should write more legibly. Sorry. All right. So this is going to be easy, -20. And we can combine the 5 and the 4 here to make 20 there. So we'll have 20z squared, z minus 4. And over here, things are going to get really messy. So what I'm going to do is I'm going to put the 4z in front, and I'm going to multiply 2z minus 3 times z minus 4. I'm going to go ahead and FOIL that out. Again, you have to FOIL the numerators. So I'm going to do this in my head so we can save room. So FOIL 2z times z minus 4. 2z times z is 2z squared. And then 2z times -4 is -8z. And z times -3 is -3z. -8z plus -3z is -11z. So hopefully I'm not confusing you there. Don't get confused by that 4z. We're not doing anything with the 4z. And then -3 times -4 is positive 12. And in the denominator, obviously, we should end up with the same thing. So 5 times 4 is, well, we can just do 5z times 4z is 20z squared. That's a good sign because we got the same thing. And then we just have the z minus 4. So that means we did it right. We have the common denominator. So let's just double check that. I know that's a lot of stuff, but sometimes these problems do get fairly challenging. So now we're going to distribute the 4z into all that. So we get 8z cubed minus 44z squared plus 48z. Let's see here. Most of the problems that you do are probably not going to be this difficult, but you may see one like this. So the interesting thing here is that there's really nothing to combine in the numerators. There's no like terms, so we're just going to have to write 8z cubed and so on and so forth. Again, there's no like terms in the numerator. So that is the answer. All right, on to number 33. So for number 33, we're going to have to use the -1 rule, so let's do that one together. We'll factor out 9x. And you can see the reason we have to use the -1 rule is that we have 2x here, but we have -2x here. Specifically 2x minus 5 here and 5 minus 2x there. So that's they're not like terms. So we're going to have to employ the -1 rule. So let's double check. And I forgot my x there. So there's two ways we can do this. We can factor out a -1 here, and that's going to change. This denominator to 2x minus 5, which we want. And if we factor out a -1 here, we're going to end up with a -1 in front. And remember, if there's a negative on a fraction anywhere, it doesn't matter where the negative is. It could be in the numerator or the denominator. If there's a negative, that means it changes the fraction to negative. As long as there's not a negative in the bottom and the top, then obviously they would cancel out. So that means that if this fraction is negative, you could have -3x here, and then it's going to change to a positive because you have a negative, you're subtracting a negative. The other way we could do it is we could actually factor out a negative over here, and this would become 5x minus 2x, and then we could take that negative, and you could keep it down here, or you could keep it up here. But long story short, this entire fraction would become negative. So there's a lot of different ways to do this. So I'm just going to change this to a negative, or excuse me, use the -1 rule on this expression. So I'm going to factor out a negative. And again, it may not look like it, but now this factor is the same as this factor. The terms are just rearranged. You could rewrite this as 2x minus 5. It's the same thing. All right, so now I can take this -1 and I can put it up here. There's a lot of different ways to do this, or we can just multiply both sides of this fraction by -1, and then we'd have our factor. Probably the easiest way is just to move this negative up into 3x. So I'm going to go ahead and do that. There's so many ways to do this. So it's kind of hard to choose. I know which method I want to use, but that's may not be the easiest method for you. Sometimes the fastest method is not the easiest method to understand. All right. So now we still have to get a common denominator. So let's see here. So we have a 2x minus 5 here, and we have a 2x minus 5 here. So all we have to do is multiply both sides of this fraction by 9x. And please put parentheses around the negative 5 plus 2x. So then we end up with a negative 27x squared So now we're ready to combine. So this is a negative 27x squared, but you're subtracting it, so it becomes positive 27x squared. And this would just be positive 1. So that was a challenge problem. All right, so number 34 is going to be similar to 33. You're going to have to use the negative 1 rule. So try number 34. When you come back, we'll do it together. All right, we're back. So I'm going to try some different methods for number 34. So it's not going to be similar to the method we used here. If you want to use the method here, you can refer back to this problem, but I want you to see that there are many different ways to do this. Again, I'm not trying to confuse you by using a different method. I just want you to see that there are other ways to do this. So if we factor, we get 3x minus 4 times 3x plus 4 because it's the difference of two squares. And you can see that we do not have common factors in the denominator, so we have to use the negative 1 rule. Now in the previous problem, what I did is I factored out a negative 1 here, and I put the negative up here, and it changed the sign. That would make that a double negative, so that would become positive 1. So you know what, I'm just going to go ahead and do it the same way I did it before. Again, you can factor out a negative 1 here and bring the negative up. Or you can just put the negative here. There's a lot of different ways to do this, but I'm just going to do it the same way I did it before. So I'm going to factor out the negative 1. And so now, the way that we did it before is we brought the negative up. We took the negative out here, and then we brought it up to the numerator. The problem with this situation is if we bring it up to the numerator, you're probably wondering, well, what happens? Well, it just becomes a double negative. It becomes negative 1. So that would just make it positive. Now, you're going to be doing a lot of this in your head very, very quickly when you get used to this stuff. It seems like it's going really slow now. But I don't want you to get the idea that this stuff takes a long time. Once you learn the language, you can solve these problems very, very quickly. I'm going slow just because I'm trying to show every single step. All right, so now we have a common factor. Negative 4 plus 3x is the same thing as 3x minus 4. So we can see all we have to do is multiply both sides of this fraction by 3x plus 4. And then that'll give us a common denominator. And please put this around, put it around parentheses, or parentheses around it. All right. So we have our common denominator now. And again, I could switch this around so it's 3x minus 4, but I just want you to be aware of where that came from. So I'm just going to leave it. And I'll move move that over. Let's double check. Let's make sure we have everything right here. I'm going to move this down. So now we have a common denominator. We can add them up. 3x plus x is 4x, and 4 plus negative 7 is negative 3. And just rewrite the denominator. Doesn't matter if you write this factor as negative 4 plus 3 or 3x minus 4. You're going to get the same answer. Alright, so if you got that answer, good job. I'm sorry I didn't tell you about this part here where it changes sign. These problems can be really, really tricky. Like, we could be doing this all day long, just trying variations of these problems. But the important thing is that you understand that some of these problems can be difficult, and as long as you've got the primary idea and you can do the basic types of problems, then you should be ready to go on to the next class. Alright, so 35 and 36 are the last problems for the day. So let's do the first one together. We're going to factor out 5x. And here we're going to factor out 2x. So we can already see that this problem is going to be pretty challenging. And unfortunately, we have to factor even more because we have the difference of two squares here that can be factored, and we have a quadratic that can be factored. Now, we don't know if the factoring is going to help us, but we've got to do it, because if it does help us, it can make the problem a lot easier. And 99% of the time in these problems, factoring is going to help because that's how the problems are designed. So factor that quadratic, and we end up with x plus 3 and x minus 2. So now we can see that we have some common factors, but we have other factors that are not common. So we have an x plus 3 in both of these. But we have a 2 and a 5, so those are different. And we have an x minus 3 and an x minus 2, those are different. So this does not have an x minus 2. So we're going to have to multiply both sides of that by x minus 2. And it does not have a 2 either. So we're going to have to multiply both sides by 2 times x minus 2. And I think that should do it for the left fraction. So 2 times x minus 2. Again, we're just using the fundamental principle of fractions. And then this fraction over here, we're going to multiply both sides by 5x plus 3. And, whoops, that shouldn't be x plus 3. That should be x minus 3, sorry. 5x minus 3. So we're going to multiply both sides by 5x minus 3. And I think that's going to be it. So now let's simplify. 2x minus 2 times 2x minus 2 times 1. So we're just going to get the same expression. Then I'm going to go ahead and use distribution. 2 times x minus 2 is 2x minus 4. And then we end up with, let's see, 2 times 5, that would be 10. And we're going to leave the x in front. So this is going to be a gigantic problem here. You're not going to get very many of these because they're so tedious, but you may see one of them, and this really helps you with your algebra language. So let's see here. We can multiply we want to multiply negative 3x times 5 first. So then you get negative 15x. And then 5 times 2 is 10x, of course. 5 times 2x is 10x. Just rewrite the other factors. And we should have common denominators. So if we check and we have common denominators, that means we did it correctly. So it looks like it works. But we do have to distribute this first. So I'm going to copy everything here because I don't feel like rewriting that. I'm going to go ahead and distribute the numerator on the second fraction. So negative 15x times x is negative 15x squared. Negative 15x times negative 3 is positive 45x. So now we're ready to combine. So this is a negative 15x squared, but it's going to become positive 15x squared, because you're subtracting, and it's going to become a negative 45x, so on and so forth. Actually, we can combine. So 2x minus 45x is minus 43x. And again, you're subtracting because the positive becomes a negative, because you're subtracting this whole fraction. And then we just write the minus 4. Then we can just rewrite the denominator. And we're done. So you're not going to get very many of those problems, like I said, because that one was particularly difficult. So I'm going to write that answer down here. All right, so time for number 36. I'm going to go ahead and shrink this. So 36 is going to be pretty difficult, I suspect. So you can attempt it, try your best, and when you come back, we'll do it together. All right, we're back. Let's see, 72 divided by 3 would be 24, I believe. So we're just factoring out the GCFs, the greatest common factor. All right, now we have to factor again because we've got a quadratic. And thankfully, this is actually going to be a lot easier than I thought it was going to be, because we have some common factors. All we have to do is multiply both sides of this fraction by 3 times z plus 8. Let's just go ahead and do that. I'm going to move everything over a little bit. So 3 times z plus 8. Alright, so we can multiply these first. 3 times 6 is 18. And then 3 times z is 3z. And z plus 3 times z plus 8. So now we can just distribute. Now I want you to understand that it's little things like this that really make things difficult, because a lot of times teachers don't show you how to do that. That's something that we've never done when you multiply something like this with a monomial. So, but now you know how to do that. Alright, so we have 18z, and then 18 times 8 would be 144. So we're almost done here. So combine those, and we have 18z. (18z) and then negative 4 plus 144 is 140. Now we just rewrite the denominator. So we got that answer. I'm really proud of you. If you didn't get that answer, that's okay. That's normal to struggle with these more difficult problems. It's no big deal. All algebra students are going to be struggling with these same types of problems, so don't worry about it. It's totally normal. Most problems are not going to be that difficult, so that was just a sample of a problem that you might get. So this is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. Don't go before you get your homework. Get a screenshot of these first 2 pages and a screenshot of this last page. Be sure to do that homework completely correctly, neatly, and keep it in order in your binder. And I look forward to seeing you in the next class.